Okay, you guys try these? Some people did. Got your slice. Now this is just review. Your test is tomorrow. Okay, individual. Very first one, but we can switch to the. Pardon? Yes, I guess we're doing that. But you have to try on your test to drop a test. So if those people who just turn in a blank test, that's not going to get dropped. Yeah, it's not going to get dropped. You have to put some effort in. Real, honest to God effort. Okay. Okay, guys. This is not the unit you want to drop because this is the unit for sure you're going to have this on your exam. So you need to master it. It's not that hard. This is just area. Now your test tomorrow is individual. Don't forget to look at 7-1. Okay, guys. This is it. This is the only time we have to review. Okay, 7-1 is on the test. That was the acceleration, velocity, and position. You have some good problems on the multiple choice that we actually did in class. So, if I want the area of one of these little rectangles, I'm going to add them all up, but how do you find this length right here? That's the height. Right, y1 minus y2, so it's f of x.
Did you see that? Well, that's not you in it.
And then we're going to add them up, and what's the base? Dx. From where to where? A to B. This one, I'm not going to slice vertically. I've got a problem here, right over here. I got a problem there. So I don't want that. We're going to slice it the other way. Okay? So we're going to slice it this way. And so this is x1 and this is x2. So what's the area of one of these slices? We should all get this because we did this in the last chapter anyway. So it's x1 minus x2. What's the differential? dy. And then we'll integrate that. So what I have to do on these types of problems is I have to, if this is y, I have to solve for x in terms of y. So x is going to be some function of y. I don't know if my notation's exactly right, but I think you get the picture. And so it's going to be, that was my first one, so it's f of y minus, solving this one for y is g of y. Actually, probably should be inverse, but that's okay. dy. And we're not going to integrate from a to b. We're going to integrate from where? F of a to f of b.
Wait, why is it?
Because it's y. It's not x. These x's are a to b. So that shouldn't have been too bad, right?
It's okay. Wait,
Oh.
we go back.
Yes. I don't want to spend too much time. Yeah, it really should have inverses there, but that's okay. You know you're going to solve this function in terms of y. I put inverses in there, it's not nice looking. Okay, so I want to find the volume. I'm going to rotate this around the x-axis. Whoops, a little bit off. That's okay, it happens to you guys too. And so if I slice it, it looks like this. And what's the radius? Yeah, r is equal to f of x. Don't forget the pi. So the volume is pi radius squared, but that's f of x squared dx. In this case, it's going to go from 0, and I didn't give a name here, so I called it a. Didn't think about it when I wrote it.
Would we have to put, or would we get points off if we didn't give like from like this point to this point? If there weren't any?
They'll be on there. Girls. If you're allowed to use a calculator, you must write this equation. They will not look at the calculator syntax.
I understand that.
Do you do this? Equals whatever it is. Yeah. Look at the scoring rubrics are online, so go ahead and look at them. Do the problems. You know the years. You just have to go and look them up. Okay, this one we're going to rotate around the y-axis. Did you guys rotate these things? And is this going to be a disc or a washer? A disc. It's like a bowl. And the radius is equal to x. So we're going to have to solve for x in terms of y. So the volume is going to be pi radius squared, so it's f of y squared dy. And we're going to start here at 0, and we're going to go here. Let's call that x equals a. So that would be from 0 to f of a. Should have put that in there. Sorry. A is right here. Now we get a little tougher, right? I think this is the one where I messed up and I switched these. But that's okay. I just switched the directions on the bottom of the page. Yeah, that's the one I messed up. Okay, you ready? We'll do the x-axis. On the answer key, I have them reversed. Is it easy to do that? To reverse them? Yes. And on the multiple choice part of the test, I can do that to you. Now, what kind of shape am I going to get here?
Washer. Not really. So,
Well, just look at the geometry. You see the washer there? How do you find the volume of a washer, Zach? It's pi. It's the area of the big circle minus the area of the little circle to get the area at the base. Remember that from geometry. Times its height. Well, its height is either delta x or delta y. Which is it? Delta x. And that determines the variable. So now I got to put the radius in there. So here's the little radius. What's the little radius equal to? B of x. And the big radius goes up to this curve. So capital R is f of x. Does it matter if you get the order right? Yes, this is subtraction. It's not commutative. Okay, so what's the answer? It's pi, big radius squared, so it's f of x squared. And I don't memorize this, I draw the pictures. Minus the little radius squared. And that's a problem if you're memorizing. And where are we going to integrate from? 0, and should we call this point over here a? X equals a. It doesn't matter. Yes, you can call it whatever you'd like. Is that okay? Pardon? I just named it a. I don't. Now this one's going to be around the y-axis, right? Okay, first you understand you're just going to reflect it over the y-axis as best you can. That's not too bad. This is kind of like a weird shaped bowl. If you need to shade to see it a little bit better, does that help you see it better? Yes, you can. And this is just a circle, a squished circle. The calculus is just putting it into the integral. So, what's the little radius? Which function is that? That's f of x. So then the little radius, r, is equal to f of y. What's the big radius then? Yes, big radius is g of y. So it's pi, it's the big radius squared, and so you've got to make sure you get these in the right order, minus the little radius squared. Whoops, that's not g, is it? That's what? F of y, right? And don't forget to square it. Sometimes if they have squares in there already, you can forget to square it. It's dy, and we're going to start here at the bottom, so it's going to start from 0 and go up here. This is a. What's the height? F of a. What's the function at your q? I'm going to call it q. If you can do this, then you can, I mean, all the problems are going to look like one of these. They're all. Now that's not too bad, so we get to the next page. Now we're going to rotate around x equals k. Now on the exam, Luke, I always see an area problem, And sometimes I see cross sections. Sometimes I see them rotated around the x or y axis. Sometimes around other lines. And I can't predict which way they're going to go this year. Because the one year they rotated around a horizontal and a vertical line and did area. So if you didn't know how to rotate around a vertical line or something like that, you were stuck twice. I would like to have seen a combination, but they didn't. So you really have to know all of these. And so we're going to rotate around x equals k. And this, to me, is the hardest type of problem right here. That's not too bad. It's not great, but okay. So I'm going to draw this in. And it's the radius that's going to give us the trouble. And remember, we always draw a radius to our original curve. So here's the little radius. That is not the x value. This length is the x value. Do you see that? Okay, do you guys see that? That's the hard part. But that's geometry. Now, some of you can just look at it and tell me what r is. Some of you can't. Because this is the inside radius. The big R is this length. That's a bigger radius, isn't it?
Why we use x and not r though?
Pardon?
Why we use x?
Because you would need to do pi r squared minus little r squared. And is this dy or dx? dy. So your r is going to have to be a function of y. But to get it set up without looking at my functions, I'm just going to do the geometry here. What's true about this distance? That's the x-coordinate on that curve. X plus little r, call it x1, has to equal what? What is this whole thing? K. So some of you will say r is equal to k minus x. 1. So solve for r. What about the other one? This x, this is a different x, that's x2. x2 plus capital R is equal to k. So what's capital R equal to? K minus x2. Yeah, but we have to be in y's, don't we? That one's harder than this one. I should have done this one first. So it's going to be, give myself some space, maybe. We'll have a k there. Sometimes they actually put k in. They don't say it's 3. They call it k. Just remember, it's just a number. So it's pi, and it's the big radius squared, so it's k minus, now the big radius was this x2, that was f of x, so it's f of y, isn't it? Squared minus, then we have to do this one, which is k minus, and this little r has to do with g of x. So x1 is equal to g of y. Really should be g inverse. I do want you to realize that. That's dy, and then we will integrate from 0 to where? The function at k. G of k or f of k, it doesn't matter. They're the same. So you're going to get weird looking things like 10 minus something. And we can do a problem like that too if you want, if you give me something off the yellow packet. You have to solve for x in terms of y. Because this tells you we have to have y's.
You have to hit both of it.
Nope, it gives me everything. Because the washer comes in and goes, picks up this everything. All the way around.
Oh, wait.
Because that's 3-dimensional. We're going up this way. Yep. Yeah, it can be confusing. Let's rotate this around y equals c. Well, that's a little bit better. Okay? Which way are you going to slice this one? Okay, vertically. Okay, Adam? This one will be easier because I have them in the right. I have f of x and g of x, so it'll be a little easier. Now, what's the little radius? That's this length to the inside curve. That's r, but that's not the y-coordinate. This is the y coordinate. That's right. So little r is going to be c minus this y value, or c minus, and that turned out to be f of x. Does that make sense? Does that make sense, Luke? Okay, what's capital R? It's going to go from the axis of rotation down to this curve. So it's going to be c minus g of x. You have to look at the geometry. Sometimes we added the constant in there. If you remember the problems we did like that, I just don't know. So it's going to be pi, big radius squared, that's this one. So it's c minus g of x squared minus little radius squared, c minus f of x squared, and the differential is dx.
Yeah, so R equals C minus G of X, or does it say
R should say equal. Sorry. I think it's down here, just didn't come up very well. And then we'll integrate on the x's from 0 to, not c, I got to find out what the x value is. Let's just call it x of c. I don't know what else to call it. Because there's an ordered pair, that's the y coordinate. I need the x coordinate that goes with it. Okay? And this is going okay. You can do these, you're doing great.
I can do them when you're doing them.
I don't know if I have a blank one of these. I probably have had some extras. Okay. Ready to do the last two, since we're doing these? This one's easier, because this is not a washer. Rotate this region around x equals k. Kind of like a dome. So there's your slice, the disc. Okay, let's go all the way over there, sorry. My board's a little bit out of alignment. Oh, and there's my radius. How do I find my radius? It's not x. Excuse me. Thank you. This is k. Can't see it there. So what's little r, Adam?
Little r is going to be the constant minus the x value.
No, not fx. X. What's the differential? dy or delta y? Delta x. It's dy, because it's this thickness here. A quick check is if you were to slide it over, it would hit the y-axis. It's just a nice way to do it. Yeah?
Is that shape fully?
Because I'm not looking at what the function is. I'm looking right here that this distance on the x plus this distance on the r has to add up to k. I'm not putting the function in. Not yet. I will. So, it's going to...
This isn't a washer.
Nope, it's a disc. And then we'll do cross sections. Could have made another one like this, but I didn't. Okay, so it's going to be pi, and it's the radius squared, which is k minus x squared, and it's dy. Oh, and I'm going to go from 0 to where? It's the y's, not k, that's the x's. F of k. Okay, what's wrong with this? It has an x in it, so what we have to do is solve x in terms of y, so x, we'll call it is some function in y. So that's what it's going to look like. Pi, 0 to some function in k, and it's k minus f of y. So it might be a couple terms, I don't know. I can check it with my answers to see if it... No. There's no 2 there. No. You guys, the disc, do I have a disc? The disc goes around, like think of a quarter, it picks up all this volume here. So that part is taken care of. This is way different when I do the cross sections. No, this is not cross, this is, well, that is cross sections of a circle. So in that sense I am. These are created because of the rotation. This is created because I'm putting some squares in here. They're coming out at you. Where's my model? I saw it. This is this problem. Now be careful. They might be perpendicular to the y-axis. In this case, it's x. So it's this model right here. So this guy is coming out at you. These are the easiest ones. Because what's the area of my base? It's a square. There's no pi. So it's s squared times delta x or delta y. Delta x. So, okay guys, the volume is equal to s squared dx. And what is s equal to? It's equal to which value? X or y? It's equal to y. So s squared is equal to y squared. What's y squared equal to?
4 minus x squared.
Yeah.
What is S equal Y?
S equal y.
Hold it. Because this is the side of my rectangle. And how do you find that length? Isn't it the y coordinate on my circle? Okay, you guys, you see that? This is the y coordinate. Had I been perpendicular to the x-axis, it would have gone this way. But it's not that. It's perpendicular to the x-axis. Did I say that backwards? If it had been y, it would have been horizontal. So this is the y coordinate, and that's what it looks like. We have to integrate from, what's the radius? No, 2. So from -2 to 2. Or could you double this one, because these squares, now it's different than that other one. These squares are just kind of going along here. Isn't the left side here equal to the right side? Yeah. So volume is equal to, it doesn't matter, either one. 0 to 2 of 4 minus x squared squared. It's not r minus r squared. That's not what it is. Whoa, one at a time. What? These are square cross sections. It's a whole different problem.
But it's just different ways to solve the same thing.
No, that was created by rotation. This is like a deck of cards. I'm creating it by putting a bunch of rectangles together. Think of a deck of cards. Each cross section is a rectangle, isn't it?
Both kind of like this shape.
I don't really care what it looks like, but what this would look like if I can draw it in 3 dimensions, I'll do the best I can. Actually, we do have the model. This is the y-axis. This is the z-axis. So my circle is going to look like this, and my cross sections, it's like a bicycle helmet. Look like this. They should be coming out at you. And they're going to get taller the closer I get to the axis. So it's this shape, and you would, on a bike, kind of like a bike helmet, if you were to draw these lines down here, it'd come to a point.
But it's only one way. It's not like a...
Right, I'm not doing a rotation. I'm building like I build a deck of cards.
I get this.
Since 4 minus x squared is already equal to y squared, do we need to square it again?
Oh, did I mess up? I think I did. That is y squared, so you're right. I don't want the squared here.
Why? You want this to be like
I don't want to, because y squared is that. Because what? No, because what's y? It's the square root of 4 minus x squared. So y squared is getting rid of the radical. Doesn't matter. This is not there, because that is y squared. This is s squared. It's already squared. It is. S squared is that thing, because y is equal to this. S equals y, so s squared equals y squared equals the square root of 4 minus x squared squared. So it doesn't have the radical.
When it's going from 0 to 2, you don't get both sides.
Oh, I just doubled it. I forgot the 2.
Where did we get S from?
This is the side of the square. Okay. Do you have specific ones you want to look at in this packet?
just get it right.
We did 2009, but if you want to look at one that doesn't look like that, we can. And so we've done the front page, I believe. Or didn't we? We've done 2005.
We do 2004.
How long?
If I find it. Now, after your test, I'm going to assign the 2011 and 2010. 2009 is a nice little one, too. Where do we find... Yeah, you should do those, but they're without a calculator. Which one's 2004?
Second stage.
That's a fun one. There it is. Missed it. Okay, let's do 2004. Okay, you guys? Okay, you guys? The B, this is your yellow packet. The B's are the exams they take in Europe. Okay, so these are the exams they take in the U.S. And if you are absent on the AP day, okay, you guys? Because for whatever reason, there is an alternate exam for you, and I never get to see that, ever. So there's a makeup, so there's 3 exams, unless I get lucky and get to grade that one. But then I have to swear on my deathbed I won't reveal anything. Okay. Do the whole thing, area 2? Okay. A. Find the area of the shaded region. Oh, let me label these. We all know what f of x and g of x are, and so do the readers. So you may just use f of x and g of x. If you prefer to put the formulas in, you may. You don't have to. Find the area of the shaded region enclosed by those 2 graphs. So I'm going to draw a slice.
Rectangle.
It's a rectangle, right?
Which one are we working on right now?
This is 2004, number 2. How do you find the height? Adam, how do I find the height?
By subtracting 1, yeah.
Well, which is it?
UMax,
Which one's bigger?
after this is bigger, but
So it's f of x minus.
actually go on.
I don't have to break it into 2 regions. Because f of x, the area under f of x is this piece, and this is 0 minus this. G of x is negative, so that's going to become positive. So that the area is going to be equal to the integral of f minus g. What's the differential? dx. Remember how I said later on the differentials would start making sense? And at the time when we first did it, they were very confusing. And I'm integrating from 0 to 1. Do you have any problems with your calculator? We're to set them up. You get 15 minutes of problem. Like Mrs. Hersman says, you can't be like daydreaming during this test. You don't have time for that. Okay, find the volume. I'm going to rotate that around y equals 2. So I'm going to redraw this thing. Okay, I do not have enough space, so you know what I'm going to do? I'm going to make it smaller. Okay, you guys, you have it drawn?
Your clock's broken, my love.
Oh, okay. It is 10:49.
That's not close.
Okay. I know I can cheat. Okay, you guys. All right? Is that equal distance? Yeah. That's not too bad. It's kind of a weird shape. Okay, make sure you read the directions. It's not x equals 2, Adam. It's y equals 2. So I want to slice this. Which way are we slicing it? It's rotating around at you. It's sort of like a donut.
No, it's a washer.
It's a washer. Yes. I make it big. That's why I shrunk it. Oh, it's not too bad. And this is 2. Now remember, when you do your radius, okay, guys, you always go to the original one, not the reflected one. So we start with our axis. This is little r. Okay, can you tell me what little r is? This is the hardest part right here. It's 2 minus that. What function is that? That's f or g? That's f. So little r is 2 minus f of x. And f of x is that ugly looking formula, 2x 1 times 1 minus x. Okay, Alexa, question? What's big R? Okay, shh. Okay, chat needs to stop. What? Because the formula is pi, big R squared, minus pi, little r squared. It's the area of the big circle minus the area of the little circle times the thickness. That's the inside radius. So the outside radius is going to go from here down to this function. So what's capital R? This is deceiving. It's 2 minus g of x. Some of you are going to say, wait a minute, it's 2 plus g of x. No, g of x is a negative number. Because g of x is underneath here. So g of x is always negative. So when you do 2 minus g of x, it becomes a positive number. Does that make sense? Am I right? Just blindly trust me. Okay, so it's pi, big R squared, which is 2 minus g of x. And we can bring up the answers. Minus little r squared, 2 minus f of x. And honestly, I'm on the exam, I'd rather write it that way. And I would put f of x in y1 and g of x in y2. dx. And this is what you have to show. You can't show calculator syntax. And where are we going? Oh, the x's go from where to where? 0 to 1. And I have no idea what it is. The answer is 16.1 what? Did everybody get that? Well, I can bring up the answers. I would, this is a tricky one to enter, but you know it's 1 point. In y1, I would put in my f of x function. And in y2, I would put in g of x function. And then I would enter it pi, fnint. It's up to you, but I would go 2 minus y1 squared minus 2 minus y2 squared, a lot of parentheses, comma x, comma 0, comma 1. If you want me to do it, I'll do it. Do you guys agree? We have to finish this. Don't you want to finish it?
Yeah, letter C. I mean, letter C is really hard.
Well, because there's a lot of reading.
Yeah, it's too much.
It will clone that. I know, it scares me. I'll be honest. I look at that and I go,
I have a question.
Yes.
So for like, we did circle one's like the circle white sheet that were tweets, lines, the kind of asking how do you know which one?
You have to look at the geometry of the situation. Yeah, you want to memorize, can't. Don't memorize, not going to get you anywhere. Okay, ready for the last one? Okay, shh. It says h is the function. I'm going to write that down because there's a lot of reading here. It's kx times 1 minus x. And x is between 0 and 1. And it says, k is positive. The region not shown enclosed by the graphs of h and g is the base of the solid with square cross sections perpendicular to the x-axis. Wait.
I didn't know you.
Pardon? I'm on the way. Yeah, all we have to do is write it. Oh, it's H and G. Okay, so they didn't draw a picture of H and G. But if you look at F, what is F of X? F of X is 2X, 1 minus X. So all they did was change the 2 to a K, which is your vertical stretch. So instead of F, we can call that H of X. And it says now that I want to find the volume of the solid created by square cross sections. So that's this guy. They're coming out at you. I don't know what it looks like, but it doesn't matter. How do you find the side here? That's this length. This is H and this is G. That's right. So the side is equal to H of X minus G of X. What's the thickness then? Natalie, what's my thickness? Dx or dy? That's right, because it's perpendicular to the x-axis. Okay, so we are going to integrate h of x minus g of x, because it isn't the original picture anymore. Pardon? I don't know what, I don't know. I know it has that shape, that's all I know. All this k does is makes this steeper. That's all. So you're going to have an answer with k in it. You're going to integrate from 0 to 1. And what do I have to do with this side that I haven't done yet? Square it. Dx, that's equal to 15. And that's done, because they didn't ask you to integrate it. If you wanted me to substitute the functions in there so you see there's a k, I will do that. You don't. They told you that. So it's kx, x minus 1, minus, where's g of x?
3 times x minus 1 times the square root of x.
Gotta make sure I got my parentheses there. And they say, find k, so if that's equal to 15, that's all you have to do. You don't have to solve it. That's it.
Then do you know when you need to square both terms or just...
Because when you get the washer, it's r squared minus r squared. But if it's the side of a square, it's going to be the difference in your y coordinates, quantity squared.
I'm still lost. I don't want to use like R and Y.
You have to look at the geometry of the situation. Best thing to do is to do another problem. Pardon? You have to look at the geometry. You have to draw the picture. No, you want to memorize a rule. There is none. No, guys, don't memorize rules. There's way too much stuff. Just draw the picture. But those are skill things. Okay, somebody said something about the pink worksheet.
Yeah, me.
Looking at problem number 2. May I borrow this?
We're at 67.
I don't know, but I have the picture kind of on the board, but let's start again. This is pink number 2. X plus 2y, and I think this is a good problem. Okay, that's all I need. Thank you. Okay, you guys. You're bounding up by the axes. What? Now, you guys, do you know the easy way to graph lines? Natalie? The easy way to graph lines is to let x be 0, then y equals 4. If y is 0, x equals 8. So this is going to be 4, and this is going to be at 8. Somewhere like that. Okay, shh, girls, this is all the time we have. Don't forget, I am available periods 5 and 6, 1304, and tomorrow morning. Okay, you guys, this is the protractor problem. Carolyn, how do we do this? These are semicircles coming out at you.
Why can't you do rectangles?
Because it said they're semicircles. And I actually kind of have a picture over here. I do have a picture of it over here in 3 dimensions. They do. I have one here too.
Yeah, I thought it was right there.
They're perpendicular. I can't draw it that way. Okay, can you see the picture over here? There's one right here. So it's kind of like coming into a cone. Like a tunnel that has no end, unfortunately. It has an end. Okay, so, but I don't really care what it looks like. I just want the volume of this, which means I have to find the area of the face. Is it dx or dy, by the way? Dx, okay. What's the area of my face? 1/2 pi radius squared. Okay, Christian, pay attention.
You just said this.
It's a semicircle. It's a semicircle. Circle's pi r squared. Semicircle's half. Now, I need to, shh, guys, Alexa, how do I find the radius? Well, then you need to pay attention. This is what? That's the diameter. So the diameter is equal to y, but so the radius is y over 2. Now you got to be careful with this, because it's the radius that is squared. No? Not quite yet. So it's the integral of, it's 1/2 pi, and it's r squared dx. Guys, be quiet for a couple more minutes. I'll be done sooner. Okay, r squared is, what's r? It's y over 2. And you are going to square the 2, which makes that what? 4. And I'm going to bring the 4 out, so I'm going to have 1/8 pi y squared dx. Now all I have to do is figure out what y is. By the way, what were the x's? Because I did the work already. It starts at 0 and it ends at 8, right? And I just have to solve for y up here. That's an 8. So 2y equals minus x plus 8. So y equals negative 1/2 x plus 4. Okay, Cole? It does look like a 1. It's an 8. It's 1/2 x minus 4, right? Negative 1/2 x plus 4. And then don't forget to square it. That's why I do everything in terms of x and y. And then I put the functions in at the last minute. Because it's 1/2 that's squared. It is pi over 2. I have pi over 2 right here. Then it's y squared over 2 squared. And I pulled the 2 squared out and made it 1/8. Now it's time to go. Kind of. Okay, you guys got to practice.